Imagine you have a clock which has two mirrors, one at the top and one at the bottom. Now imagine there is a photon between the mirrors bouncing up and down at the speed of light c. Now let's say the distance between the mirrors is d and the time which is required to cover the distance is t. Now let's say t is equal to 1 second, which means that it takes the photon 1 second to cover the distance. Now let's say you have one more clock like this one and you give it to your friend. Now there are two clocks. Now suppose that you stay on earth with one clock and your friends jumps on a rocket with another clock and starts to travel in the universe. Now there are two things that you need to understand. First, the laws of physics remain same in both conditions, whether you are stationary or moving at a constant velocity, which means that if you are like in a train, for example, which is running constantly at the rate of 60 kilometer per hour, let's say, and so in that case you will not even feel that you are moving if you close all the windows of your coach. That means that you cannot tell that you are moving unless you look outside. So that means that laws of physics remain the same even if as if you were not moving at all, if you are moving at a constant speed. Now the second is speed of light is constant. For example, let's say you are driving a car and you throw a ball into the moving direction, then what should be the speed of the ball? It will be the speed of ball plus the speed of car. But if you turn on the headlights, what will be the speed of the light which is coming out of your headlights? Which will it be the speed of light plus the speed of car? No, it will still remain the speed of light. It will still come out at the speed of light. So that means that no matter what happens in all the conditions, speed of light remain unchanged and it always remains constant. Now back to our example. Now let's say your friend goes faster and faster in the universe and he keeps traveling in the universe. Now here's a question for you. Because of the fact that the photon of his clock has to travel a longer distance, a diagonal path up and down and forward, wouldn't you see his clock ticking slower than yours? Because the photon of your clock has to go just up and down, and the photon of your friend's clock has to go up and down and forward. So it has to travel a longer distance, a longer diagonal path. So wouldn't you see his clock ticking slower? Because the photon cannot increase its speed because it is already traveling at the speed of light, and the distance is has been the distance has increased. So yes, you will see the his clock ticking slower than yours. But will he experience this too? Well, no, because of the fact that the laws of the laws of physics will remain same for him. He will not even feel that he will not feel that his clock is ticking slower than yours. So that is called time dilation. It means that if your friend goes into the universe and travel faster and faster and returns after 1 year, then for him it may be 1 year, but on earth it may have passed many years. You could grow old in just a year of for him, which is a year for him could be many years for you. So this is called time dilation. It is very unbelievable and fascinating, but it is a true fact which has been proved many times by the scientists with the help of some very precise machines like atomic clocks and stuff like that. So and your friend will not feel that the time has slowed down for him because his thinking process will also slow down accordingly. So for him nothing has changed, but for you the time has slowed down for him. So this is first this fact was first deduced with the help of the special relativity, which was introduced to us by Mr. Albert Einstein. And this called the theory of special relativity. There is another theory which is called the theory of general relativity. In this case, we have to consider gravity and acceleration too. So this is another type of time dilation which says that where gravity is stronger, the time will slow down. So we will discuss about this in later video. um, so guys, thanks for watching.